Hello all, today in this video I am going to make a continuation of the previous video only. So previously we have worked with this email spam detection data set with the different deep learning algorithms like a simple RNN, then LSTM, bidirectional LSTM, that is BiLSTM, GRU, and in this work we are going to work with convolution. So previously this bidirectional is providing the better results, then comes the GRU, then LSTM, and then only RNN. So in this work we can just confirm that whether this convolution layer is providing better results than this every deep learning algorithms or not. So this is a continuation of the previous video only. So I am just making an overview. So if you want to see a quick on the neat description of every algorithms, means you can just see from the previous videos itself. So we can just give us see a quick overview. So first we are just loading the loading the data set. This data set we downloaded from Kaggle. You can just search it as email phishing detection dataset Kaggle. In that case, you will get this dataset. So this dataset is having nearly 3 entries, which are unnamed, email text, and email type. So we are checking whether this data set is having any null entries. Within the email text, it is having some null entries. So we are using the fillna function. Then we are determining the x variable and y variable. Here the text serves as the x variable and label serves as the y variable. So within the text we are calling the email text, and within the labels we are calling the email type. Then we are using the label encoder function for pre-processing. It works with the labels. Then we are making a plot. This plot is optional only. It is made based on the number of entries, how much number of safe email and phishing email is having in the data set. Then we are making use of the train test split function to determine variables like xtrain, xtest, ytrain, and ytest with make using of text and labels, and the test size as 20%, that is 0.2. Balance 80% will be used for testing. Then we are tokenizing our data set, which is making use of the tokenizer. Why? Because we have to convert the data within the train and x test into integers, and also we have to check whether it is of uniform length. For that, with use of the tokenizer, we are using paired sequences. So the output we got from the paired sequences only we will be using for every models. The first model which we have used is RNN, which is considering of layers like sequential, embedding, simple RNN, dropout, dense, and optimizer. So here we have also worked with some different RNN combinations, like we have used a dropout layer. So in this combination, so within the next we are working without the dropout, then without this learning rate in Adam, then with some different learning rate in this Adams, then some different dropout rate with this dropout layer. So likewise we have made some different combinations, and also we have made some comparisons regarding that. So we have got the values for loss, accuracy, validation loss, and validation accuracy for every model. For every models, whatever combinations we try with RNN, more or less it is same only. We can't notice much difference. We can notice some difference, but not much difference. Then we are working with LSTM. So the only difference which will vary within the every models is this layer combination and embedding layer. Some algorithms will make use of this embedding, but some algorithms will not work with embedding. When coming to this LSTM, it is also using embedding, and in place of simple RNN, we have replaced with LSTM. With we have given some units as 100. Then all others are same, and we have got the values for accuracy, loss, validation accuracy, and validation loss. Then we are working with BiLSTM. BiLSTM is also same as LSTM only, but here we will be adding another line like bidirectional. So here you may notice bidirectional. Then we are working with the GRU. With the GRU, it will also use the embedding layer, and in replace of other layers like simplernn, bidirectional, then LSTM and all. Here we are working with GRU. Then we are determining the values for accuracy loss, validation accuracy, and validation loss. So in this code, we are going to work with CNN. Here also it is using the embedding layer, and convolution 1D layer is used. Filters as 128. Filter for kernel size activation. Here we are using the flatten layer also. Previously we would not use this flatten layer. Here we have used this flatten. Why? Because we have to convert this 2D tensor into an 1D tensor. For that we are using this flatten. So this is the layer combination of this CNN algorithm. So by this we are working with 10 approaches, and we have got an value for accuracy loss, validation accuracy, and validation loss, and we have made a comparison plot also. So previously with all the models which we have worked, GRU is providing the better results, but now if you notice means BiLSTM is providing the better results, but now if you notice means this somewhat pink color. Now if you notice here it is there. So that is only the CNN, and it is only providing better results. So now it is like CNN, bidirectional LSTM, GRU, LSTM, and then only RNN. So in the next video we will be working with some other deep learning algorithm. Thank you.